So, hello everyone. Thank you for attending to my talk, the Almost Complete LDAP Guide. And the reason I put to choose the word guide in the title of this talk is because I actually put bits of information inside the slides, and I think it can really help you if you try to make better LDAP detection or be better at your LDAP traffic monitoring. So I really hope you find it useful. So, who am I? My name is Sapir. I work as a security researcher in the identity protection group at CrowdStrike. And basically, I love everything related to identity. So, AWS Identity Center, Azure Entra ID, Active Directory on-prem, and Okta. So, today we are going to speak about LDAP. So, LDAP is Lightweight Directory Access Protocol. And it's quite important to say that this talk about only one directory type, which is the Active Directory. So we know that in Active Directory object, we have different attributes. So using LDAP, we can actually query and modify these attributes. So you can see here the example. I search for the DN attribute inside the base DN users, and we're going to speak about all of these things later. So maybe you're asking yourself, people still use LDAP? So I'll just delegate permissions to Twitter to speak on my behalf. People definitely still use LDAP, and it's very much still relevant. So what are we going to speak about today? So we start speaking about LDAP usage. So who uses LDAP and why? Then we'll speak about the LDAP traffic flow, so initialization, connect, and bind functions. Then we'll talk about encrypted LDAP sessions and how to decrypt GSS-API encrypted LDAP sessions. Later, we speak about Active Directory web services. And then we see some attack tools and enumeration techniques. We speak about how we can detect those. And finally, we see how we can use LDAP for defense and what we can do with ETW when it comes to LDAP detections. So let's start with usage. So maybe you think to yourself, okay, LDAP, we know attackers use it to enumerate victim environment, and that's correct. So we know tools like Bloodhound, like AD Explorer, and we'll talk about them in more depth later. But also maybe IT administrators can use LDAP to get information about their environment, the users, the administrator groups, etc. And there is also another party that uses LDAP by default, and it's quite important to speak about it, which is Windows. So Windows uses LDAP by default in many, many cases, and it's quite important because if you want to create good LDAP detection and avoid a lot of false positives, you should know the golden image of LDAP traffic in your environment and who uses it and why, and how you can differentiate the default behavior and the attacker's behavior, because a lot of time they're kind of similar. So I gave you two examples. The first one is GPO. So you can see the query here for the GP link and GP options attributes. And actually, you may think to yourself, this is a GPO enumeration query. And that's actually correct. A lot of attack tools perform this kind of query. But this is also the output of the GP update command. So this is actually screenshot for traffic I recorded after performing the GP update command. So this is not a GPO enumeration. And just a bit of spoiler, the way to differentiate in this case between the attacker's behavior and the default behavior is using the time limit. So for GPO, GP update command, it will always be 240. And this is quite a good way to differentiate these two cases. And the second example I provide is the GMSA. So each time you want the service to run in the GMSA account password, you need the machine to retrieve the MSDS managed password attribute from the Active Directory. So basically, it might look like an attacker tries to read your GMSA password, but this is also just how GMSA works. So again, here we will have to find a way to differentiate the default behavior and the attacker's behavior, and they're quite similar, as I mentioned. And this kind of leads me to this slide, which is the plan. So the plan is to know LDAP the best we can, and then it will be easier for us to detect LDAP anomalies. And maybe I should even say that the plan is to know LDAP better than the attacker does, and then it will be easy for us to catch it in the places that doesn't aware that it looks anomalous. So let's start to speak about some LDAP basic concepts. So first we have the base object. This is basically the folder that we are going to search in, and we can control the depth of the search using the scope attribute. So for example, if we choose the whole subtree, we will search the folder and all of its subordinates, but we can just search the current folder or maybe child folder, and it's quite important because it has great effect on the amount of the results we are going to have. Then we have the dereferences attribute. So this one is quite important because actually the LDAP implementation for Active Directory doesn't support aliases. So this should always be 0. So it can be quite of a quick win to make sure that this attribute is always 0 in your environment. Maybe attackers use it to color their packet or something like that, and then you can catch them. So this one doesn't supposed to bring you any false positives. Then we have the size limit, which just limits the size of the response. And then we have the time limit, which limits the just create a timeout for the request. Then we have the filter, which is quite important, and we'll discuss about it in more depth in a couple of more slides. And we have the attributes. So the attributes are quite important as well, because this is like what is the information that we want to get about the object that fits the filter we provided. So for example, if you want to read its distinguished name, it's not the same as if you want to read its key credential link attribute. So there is quite of a heavy weight about what the attributes that we're trying to look for. Also, different attack tools uses different set of attributes. So we'll see later how we can use it to sign specific attack tools. So let's speak about the implementation. So the first thing we need to do when we create LDAP traffic is to initialize a connection towards our LDAP server, which in our case will be the domain controller. So we have two functions that allows us to do so. The first one is the LDAP init, and the second is the LDAP SSL init. So most of us know the LDAP init function because its default port is 389. So a lot of us think that this means that the LDAP traffic is not encrypted, but it's actually not correct, because using the LDAP set option function, we can control the encryption of the traffic. So actually, we can have LDAP traffic using the LDAP init function and port 389, and it still will be encrypted. So it's quite important for you to be aware what kind of LDAP traffic you have in your environment. Is it encrypted? Is it unencrypted? Is it the same as you expected it to be? So the LDAP SSL init default port is 636. So again, if you're monitoring LDAP and you only monitor port 389, you don't monitor LDAP-S. So it's quite important as well. And also we have the LDAP global catalog ports. So we have the 3268 and 3269 ports. So again, it's quite important to understand there are 4 different ports that represent LDAP traffic, and all of them can be encrypted and unencrypted. So you should be aware of that. After we initialize the connection towards our domain controller, we perform the LDAP connect function. But actually, if we don't do it, then the LDAP bind function will do it for us. So the LDAP bind function responsible for the authentication. So this one is very important. We have 2 functions here as well. The first one is the LDAP simple bind S function. So this function just gets a domain name and password, a username and password, and just creates clear text authentication. So you can see here, if the authentication type is 0 inside your LDAP bind request, you actually have clear text credentials in your environment. So you should make sure you don't have this type of authentication inside your LDAP traffic. So this is the first type. And maybe we should ask ourselves, why do we need authentication in LDAP? Because by default, every domain user has the permissions to read Active Directory attributes. But first of all, we need to remember that in LDAP, we can also modify attributes. And for that, we need a specific user, obviously, with specific permissions. Second of all, some attributes can't be read by any user. For example, we mentioned before GMSA, the MSDS managed password attribute. So this one can only be read by members of the principals allowed to retrieve password attribute inside that managed account. So again, you need to be a specific user to retrieve this information. So it's quite important that you be authenticated. And yet, there is an option to authenticate as anonymous logon user. So actually, if you take the LDAP simple bind as function and provide an empty string for user and password, you will be authenticated as anti-authority anonymous logon account. So you can see here, this authentication type is 0, and you don't have you have an empty string in the username and the password, and yet I'm authenticated. But as you can see in the bottom picture, if I actually try to perform some search operation, I get an error that I need to perform a successful bind. But later in the attack tools part, we will see that we can still brute force enumerate users in Active Directory environment using anonymous logon account, which is quite cool. So the most common bind function in LDAP is the LDAP bind S. So here we have the method parameter, and using this parameter, we can control the authentication method. And the authentication method is very important because later we'll see that the traffic is encrypted, and the key to decrypt the traffic located inside the bind request inside the authentication part. So if we authenticated with Kerberos, the key will be located at one place, and if we'll be authenticated with NTLM, the key will be located in a different place. So it's very important. So we'll see it in a minute, but here you have a picture. Just for example, you can see we have bind request. Inside of it, we have GSS-API blob that contains NTLM SSP information. So we can also have the same blob that contains Kerberos information, and then the LDAP traffic itself would be encrypted using Kerberos. So we'll see it in a minute. So now for the LDAP filter, I think the best way to understand it is just to build one. So I chose the delegation vulnerable accounts filter. So we're just going to take the 3 types of Kerberos delegation, and we're going to search an account that has any of those. So the first one is the resource-based constraint delegation. So for that, we just need to make sure the MSDS allowed to act on behalf of other identity attribute has any value in it. So we just use a wildcard to make sure it's not empty. The second one is unconstrained delegation. So here we have 2 options. The first one is the MSDS allowed to delegate to attribute. And again, we just want to make sure it's not empty, so we use a wildcard. But there is actually another option, which is the trusted to auth for delegation user account control flag. So here we have a bit different scenario because we don't have an attribute. We have a flag that contains inside the user account control attribute, and we need to perform a bit end operation on the user account control attribute to understand if the flag located inside of it or not. For constraint delegation, we have another case of user account control flag, which is the trusted for delegation flag. So again, we need to perform bit end operation on the user account control attribute. So how can we do it? We can use something called LDAP matching rules. So this is sort of functions you can apply all different LDAP attributes that perform some operations. So for example, here we have the bit end LDAP matching rule, and we can use it to search different flags inside the user account control attribute. So each LDAP matching rule has an OID that represents it. So we are going to use the OID to create our filter. So this is our syntax. We have the attribute, and then the matching rule we want to apply on, and then the actual flag we want to search inside that attribute. So now we have all the parts we need to create the LDAP filter, and all we left to do is to put an OR statement between each of them, because we want an account that has any of this value. It doesn't have to have all of them at once. So we just put the OR statement, and this is our complete LDAP filter. And now for the last subject in the LDAP parameters is the LDAP controls. So this is actually, again, a set of functions you can apply to your request, and it has a great amount of the response. So I just gave you a couple of examples. For example, the LDAP server show deleted OID will ask the LDAP server to return deleted object that fits the filter. So it's quite a powerful thing. Also, we have the dear sync OID, which asks the LDAP server to retrieve the object that changed from the last dear sync search. So this one also quite powerful, has a great effect on the response of this search. Now let's talk about encrypted sessions. So LDAP can be encrypted with multiple protocols. Here I said it TLS, Kerberos, and NTLM. And actually, we are not going to speak about LDAP-S in this talk, since it's well documented and it's also supported by Wireshark and many other tools. So I don't think my talk can actually bring something new here. But with Kerberos and NTLM, it's not the case. So as we will see later, they're not very supported or they're partially supported by Wireshark. And it's actually pretty interesting to understand the decryption flow. So basically, LDAP encrypted with Kerberos and NTLM is just a different word for LDAP encrypted using GSS-API. And it's quite important because many protocols can be encrypted with GSS-API, for example, RPC. So this decryption flow can be implemented on different protocols as well. So it can be quite useful. The only difference is that the key that we are starting with and the key that we retrieve from the byte response will be located in different places. Because, for example, in RPC, we don't have byte response, but still can be very useful for other protocols as well. So let's start with decrypting LDAP Kerberos. So what we see here in the upper left picture, we can see the LDAP message, we can see the bind response, and inside of it, we can see a KERB5 blob. So it's easy to detect KERB5 blob. We will see it in the bottom right picture. We have the KERB5 token ID. So it will always start with 0504 in Little Indian. So it makes it quite easy to understand that this GSS-API encrypted payload is encrypted using Kerberos and not using NTLM, for example. And we'll see later what it looks like when it's NTLM encrypted payload. So we have Kerberos information inside the bind response. That's what we are seeing in the upper left picture. And in the bottom right picture, we actually see the LDAP message itself. So this is actually a search request that's encrypted using GSS-API. And it's quite important to understand that this is going on port 389. So again, if you think this port represents unencrypted LDAP traffic, this is a mistake. So now we'll see how we can decrypt this information and actually present the LDAP message itself. So first of all, this is our current state. We have the GSS-API encrypted payload. We want to decrypt it. So we have a prerequisite here. So the Zoom thing. Okay. So we need a hash. So in Kerberos, it can be the KERB-TGT hash, it can be the service hash, which in our case is the domain controller hash, and it can be the user hash. So each and every hash has different effect on the decryption process since you decrypt different parts of the Kerberos ticket with it. So in my example, I will present the decryption process for KERB-TGT hash. And I also recommend using it since then you can decrypt all the LDAP traffic in your environment and not only specific sessions or traffic towards to one domain controller. So we need a hash. And now for the flow. So, okay. First, we have the AS response packet. Inside of it, there is the encrypted ticket part. And then we have a key. So we decrypt it using the KERB-TGT hash and we extract the key from there. Then we have the TGS response packet. Again, we have the encrypted TGS response part. And now we decrypt it using the key we extracted from the previous frame. So we extract the key now from the TGS response part as well. And with that key, we decrypt the encrypted IP response part inside the bind response. And we extract the key from there as well. And using that key, we're decrypting the actual GSS-API encrypted payload, and then we can get the LDAP message. So this is quite confusing using this diagram, but Wireshark kindly show us the whole decryption process. So let's use Wireshark to understand the decryption process better. So here we can see the AS response packet. So you can see here, this is an AS response packet. We can see it's already decrypted. And if we check the blue line on the bottom, we can see it actually used the KERB-TGT hash. So I provided it to Wireshark to decrypt this information. And you can actually see we learned the encrypted ticket part key. So this is the key we extracted in our first step. Now we are looking at the TGS response packet. So you can see the encrypted TGS response part key. It's decrypted now. This is the key we're extracting in this part. And again, if we look at the blue line, we can see it learned it using the encrypted ticket part key from frame 8, which was the AS response frame. So it actually tells us it took the key from the previous frame and used it to decrypt this frame. Now we are looking at the bind response. We can see here the bind response, and you can see we have Kerberos, and then we have AP response part. Inside of it, we have the encrypted AP response part, and here we have a decrypted key. And again, it used the learned encrypted TGS response part key from the previous frame to retrieve this key. And now we're actually looking at the decrypted LDAP message itself. So this was the previous encrypted payload. You can see the 0504 here and the Kerb5 blob. And you can see now it's decrypted, and not that Wireshark decrypted it for us, it also parsed the LDAP message. So we will see later in NTLM that it's not the case. So it's quite useful because we can actually walk through the pickup now and see the LDAP traffic in our environment. And again, it tells us that it decrypted it using the learned encrypted AP response part subkey from the previous frame. So this was great. Decrypting Wireshark is kind of easy to understand, but now let's speak about decrypting NTLM. So this one is a bit less fun. So first of all, you can see in this picture, we have the NTLM traffic. So you can see the bind response, that it was NTLM SSP authentication. And then you can see the GSS-API encrypted payload. So here you can see the header is not the Kerb5, it's actually the NTLM SSP verifier. So this is, again, a way to differentiate between Kerberos encrypted and NTLM encrypted LDAP traffic. And what you can see in this picture is actually the decrypted data. So as we saw earlier, in Kerberos, when Wireshark decrypts the data, it understands this is an LDAP message, and it also parses it and displays it in the main screen. But in NTLM, it's not the case. For some reason, Wireshark doesn't actually parse the information. So even if you manage to decrypt the data using Wireshark, you can't walk through the pickup and understand what going on in your environment. So it's not very useful. And now before we start to speak about the decryption process, it's a story time. So when I start working on decrypting LDAP traffic, I started with Kerberos, and it was quite easy and fun. And then I was excited to start with NTLM because I thought it would be easy and fun as well. So I found a great article that explains how to decrypt the information with Wireshark. So I started with that. And all I needed is to provide a clear text password to Wireshark, and then it's supposed to decrypt the NTLM traffic for me. So I thought, okay, easy, put the clear text password and nothing happens. So I think for 3 days, I just changed the password, record again, try to decrypt, record again, and nothing is working. So I was kind of frustrated. So I actually sent a message to the author of the article telling him that something is not working. And he told me, okay, please send me the pickup and the password, and I'll see what's going on. And then he answered after 10 minutes that it actually worked all this time, and I just didn't notice that the decrypted information Wireshark didn't parse it, so it was hidden in the decrypted data tab I showed you in the previous slide. So this was kind of frustrating. So for this one won't happen to anyone else again. The author of the article actually added an arrow. So this is a screenshot from the article, so you won't miss the decrypted data tab. And this arrow is, until this day, my greatest contribution to the security community, and I'm really excited about it. So this was kind of a highlight for me. And also during that time, I talked with Dirk Jan about the same issue, that Wireshark doesn't parse the information nicely. And I actually said that maybe I'll try to write something that shows it more comfortably. And eventually I did. So part of this talk is to present you a new tool I developed that actually decrypts Kerberos and NTLM encrypted LDAP traffic output and shows you the information in a comfortably way, and also detect some tools and enumeration techniques. So we'll see a demo of this tool later. So I actually did it, which was quite nice. And now we speak about the NTLM decryption flow. So again, we have a prerequisite. This time is the service anti-hash. Since we're speaking about NTLM, we don't have KERBDGT, so we need the service anti-hash. So in our case, this is the domain controller hash. So the decryption process is as follows. First, we have the bind request. Inside of it, we have NTLM SSP information. So we take the username, we take the domain name, we concatenate those, and we uppercase those. Then we use the service anti-hash as a key, and we create something called NT-OWF, which is NT one-way function. Then we take the anti-proof from the NTLM SSP v2 response. This is just the 15 first byte of the response. And using the NT-OWF, we use that as a key, and we create the base session key. Then, using the base session key as a key, we extract the session key from the NTLM SSP information, and we create something called decryption key. Then we use two hard-coded strings. One of them is the server seal text, and the other is the client seal text. And we create two decryption keys, one for the server messages and one for the client messages. And then with each decryption key, we actually decrypt our GSS-API encrypted payload and get the LDAP encrypted traffic. So this is great, a bit confusing, but it's implemented in my tool, so that's quite nice. I said I won't speak about LDAP in this talk, so I'm not going to. I just wanted to mention that it's pretty easy to decrypt LDAP information using Wireshark. So I presented here two examples to retrieve the keylog files, but actually there are a lot of examples to retrieve the keylog files. So you can use Frida, you can use SSL keylog in Python, and I just put pictures here to show you how the encrypted data look before and after the decryption. So we can see that like Kerberos, Wireshark actually understands that this is an LDAP message and it parses it. So it's quite nice, and you can actually walk through the pickup, and not like NTLM that it's not very useful, the information they provide, even though they decrypt the information. So as I said, you can decrypt LDAP traffic using Wireshark. I put a link to the article I used here. It's really easy. So for Kerberos, you need a GitHub file. This is just a file that maps users and their hashed password. So here, for example, you can see KERBDGT and its hashed password. For NTLM, you can use GitHub file with RC4 passwords, or you can use clear text password. And for SSL, you need the SSL keys. So you can see here the example. So here the clear text password I provided to the NTLM SSP preferences, and this is the decrypted data. And here is the SSL keys I provided and the password. And again, the data is decrypted and also parses quite nicely. Now for my favorite part. So we're going to speak about Active Directory web services. So basically, this is pure LDAP, but it hides under a cover of SOAP. So first of all, it uses port 9389. So if you monitor LDAP, you don't monitor this because this is not LDAP, although this is exactly LDAP. So what it looks like, you can see here the schema of this thing or an example. So you have the filter, the base object, the scope, the attributes, you can even have controls. So this is LDAP just in a different wrap, that's it. But it's a bit different. So first of all, Microsoft documentation says this is much faster than LDAP. So for example, if you try to enumerate a full domain, it can be maybe easier to do it using Active Directory web services. Also, you can see it when you use ETW, LDAP client provider, and we'll see it later. And we also see how you can use it, how you can use ETW to detect ADWS. It's not supported by Wireshark at all, and we'll see it in a minute as well. And it's relatively unknown. So I don't know if it's unknown because we as a defenders are not aware that attackers use it all the time, or maybe attackers doesn't really know it currently, but it's very, very important that we will be aware of that and we'll monitor this information. So basically what's going on is that we have this message going on port 9389. So this is just SOAP XML. And the minute it gets to the DC actually unwrapped it and ran LDAP query locally on itself. So as I said, this is pure LDAP. We just don't see it in our traffic. So before we continue, I wanted to say thank you to MTSec and Falcon Force because they were the only companies that actually provided really useful information about Active Directory web services, and it really helped me in my research. So who uses Active Directory Web Services? First of all, I was very surprised to hear that the Active Directory PowerShell module uses ADWS by default. So every time you run the get AD user command, you actually perform ADWS traffic. So think of an attacker that gets to your domain. It doesn't even need to install anything. You can just run the get AD user command and just avoid any LDAP detection there is. So this is quite powerful. And also there are two tools. One of them released just a few months ago, the Sharp ADWS, and there's also the SOAP Hound that actually took every LDAP enumeration technique and implemented a parallel ADWS for that. So this one quite powerful as well, because again, they just avoid every LDAP detection there is. So something interesting about ADWS, so when I started to research it, I just opened it on Wireshark. So this is after you actually said to Wireshark, okay, port 9389 is supposed to be MSNNS, and then it actually creates this thing for you. So the data part, it's just encrypted stuff. You can't understand anything from it. But then if you check the handshake part, you can actually see GSS-API here. So the minute I saw it, I thought to myself, okay, I probably can decrypt it using very similar logic for the GSS-API decryption I already implemented. So it actually worked. So my tool can now also decrypt ADWS information. So we'll see later what can we do with it. So I just put an example here, so you can see the data start with 0504. So this is actually Kerberos encrypted GSS-API information. This is, by the way, the Active Directory PowerShell module traffic. So by default, it encrypts the traffic using Kerberos, as opposed to the attack tools I tried, which actually encrypted the traffic using NTLM. So my tool supports both of the encryption types. So I'm not going to speak about the decryption process because it's quite similar. The only difference is that we don't have the bind response. So we need to parse ourselves this part and retrieve the keys, but it's quite easy to do. And again, already implemented on my open source tool. This is from my demo, so you can actually see the filter and the attributes. So you can see the filters just search the admin2 user. This is, by the way, I think just the output of getID user on admin2. So you can see how similar it is to LDAP. Let's talk about defense now. So we have multiple attack tools that uses LDAP for enumeration. We have Vlada or LDAP NomNom, AD Explorer, SOAP Hound or Sharp ADWS, and also some enumeration techniques. So we are going to cover each and every one of them. But most of them are already covered and well documented online. So the purpose of this part of the talk is not to speak about stuff you already seen online, is to try to give you something new, maybe to sign the attack tool, maybe to add on your coin detection to make it a bit more precise. So this is the goal of this part. So we start with my favorite, which is the LDAP NomNom tool. But before we start talking about the tool, there is a very important part. LDAP NomNom is a great name for a tool, and the tool itself is great, but the tool doesn't have a logo. And I think this is a big problem. So I took the task on myself, and I actually asked DALL-E to create a logo for this tool. So this is DALL-E suggestions. As you can see, each logo incorporates elements of directory services with a playful touch suitable for a tech project. So I really like this one. And here I say to the author of LDAP NomNom, please use them as a logo for your amazing tool. So what LDAP NomNom actually does? So it uses something called LDAP ping or CLDAP, which is generally used to verify the liveness of the domain controller. But here it actually used to brute force enumerate users in domain using anonymous logon authentication. So basically all you need is a network connection to the domain controller, but you don't need to be an authenticated user, which is quite powerful. So the structure of the LDAP filter here is very hard-coded, so it makes it kind of easy to detect. It's also not encrypted by default, but you can also make it in LDAP-S. So we have the NT version. This is just will be 6 always. And then we have the AAC. So this one represents the user account control attribute of a normal account, the 10. But you can also choose a different number, maybe that represent computer account or admin account, and then enumerate different type of accounts. And then we just have a list of users, and each time the tool tries a different username. And if the response starts with 17, then it means the user exists. And if it starts with 19, it means it doesn't exist. So it's really, really, really easy to detect, but it's also really, really cool tool because you don't need to be authenticated. So it's quite powerful. Now for AD Explorer. So we mainly know LDAP Explorer, AD Explorer, for its snapshot utility. So it just takes a snapshot of your whole domain. So we know the object GUID equal wildcard. This one quite know when you try to get all the attributes in the inactive directory. But actually, I found another interesting thing about it. So it's quite important to say this tool by default encrypts its traffic using NTLM, and it's actually really hard to make it encrypted traffic using Kerberos. So most cases you'll probably see it encrypted using NTLM. And I noticed that every time the domain name in the NTLM part inside the bind response is null. So I thought to myself, maybe it's something default or hard-coded. Let's check it. So there is only one call to LDAP bind as function inside the AD Explorer code. And actually, you can see it XORs the EDX register, which represents the domain name just before the call, which actually, verifies that this attribute will always be null. So this can be quite interesting to add to your detection. Maybe you'll know someone tried to enumerate your environment, but now you can also know it tried to do it using AD Explorer. Now for Bloodhound. So Bloodhound is really well documented. It's quite easy to detect because it's pretty noisy. It has a specific flow. By the way, it has some Kerberos encrypted traffic, so this might be interesting as well. So just one thing I wanted to add here is that it actually uses the LDAP server show deleted OID control, and I didn't see this in other attack tools. So this can be a nice way to sign specifically Bloodhound. So this is one thing. And I also put here a really known filter query the Bloodhound performs, and I put the English translation to this query. So you can actually use this as kind of a cheat sheet if you try to understand complicated LDAP filters. So that's quite nice as well. Now for random enumeration techniques that now are very, very common. So we have the PKI certificate template query. So since Certified Pre-owned released, I think it was 2021, the certificate template enumeration, it's kind of explode, like at least I think every attack tool performed this kind of query. But what's interesting is that each attack tool uses a different set of attributes. So you can use this to sign the specific attack tool. So this photo is example from Certify. But if you check Bloodhound, you'll see it uses a different set of attributes, but it's exactly the same search query, search filter. So it's quite nice. I also added the Metasploit query here for the security groups. So this one quite nice as well. And I added the DS internals MSDS key credential link. So if someone performs this query in your environment, it's really suspicious. And maybe it started in DS internals since Michael, the author of the tool, is the one that discovered it. But now you can see it in many other attack tools. And it's quite a good query to try to detect. Now we'll speak about how we can detect sharp ADWS. So this tool actually took every no LDAP enumeration technique and just implemented it in ADWS. So you can't detect it if you're detecting LDAP traffic. So here I use the Kerberos modules, just retrieve Kerberos users. And you can see actually the query is pretty similar to the Kerberos query we know. It looks for service principal account that has some value in them for user objects. So quite easy to detect. And something that I noticed is that each time Sharp ADWS runs a query, it also runs the following query. So if we see this, we can obviously know this is Sharp ADWS, so it's quite cool as well. But it's important to remember that we need to decrypt and parse the ADWS traffic in our environment to decrypt it. So that's important. Now we see a demo of my tool. So let's start from the beginning. Basically, I'm giving the tool first different pickups that contain different attacks. Some of them encrypted using NTLM, some of them using Kerberos. This, for example, is the AD Explorer. So you can see the bind request, you can see the GSS-API, you can see the domain null because it's AD Explorer, and you can see the decrypted data. You can see that you can't really work with it, so it's quite important to see this as well. So I give this pickup. I also give obviously our prerequisites, the service hash or the KERBTGT hash for the Kerberos parts. And I just let the tool run. What the tool does, it parses everything, it decrypts everything, it saves you all the LDAP information in a log file. And also it creates a table with detections from the data it decrypted. So now I give it the LDAP nom pickup, for example, and then I'll give it the sharp ADWS pickup. Oh, no, this is the bloodhound pickup, sorry. Okay, so now we have all the information saved into a log file. So you can just see this is LDAP information. You have the packet number, you have the encrypted traffic, the search query, the attributes, the controls, everything. And then I run a tool that goes over all the decrypted data and create a detection tables for you. So we can see now the detection table. So you can see we have different tools, AD Explorer, we have LDAP nom, and the user try to enumerate. We have some bloodhound enumeration, so for certificate and for delegation and stuff like that. So this is quite nice. Also Kerberos delegation technique. And then we're doing the same for sharp ADWS pickup. So now we're actually decrypting and parsing ADWS information. And then again, we will have the log file and the detection table for specifically here sharp ADWS. So now we're creating the table. Okay, so we can see here there is a delegation filter, and also we detect the sharp ADWS random search query for some reason performs. So this is quite nice. That's it for the demo. Now let's speak about what we can do with LDAP as a defenders. So it's quite important to understand LDAP is default. We as a defenders can just use LDAP to do the same thing attacker does and just enumerate our environment to understand what are our weak spots, maybe create honeypots, because we will know what are going to be the results of the enumeration the attacker is going to do. So if we'll do it before him, we'll know what is going to have. We know our weak spot. We know what we need to fix or where the attacker can attack us from. So I just put it a couple of examples, but there are tons of information in the internet regarding some queries you can perform just to understand your environment better and your weak spots. And I put here just a picture of the small amount of lines of code that I needed to create this detection. So it's really, really easy. And each time you only need to change the filter part to different filters. And that's it. You can create a really, really nice tool to get more information about your environment, to detect weak spots. So it's free and it's default. So I think there is zero reasons not to do it. Obviously, it doesn't cover everything, and you need the big detection tools and XDR and stuff like that. But this is something that you should do. There is like zero reason not to do it. So I put here a couple of examples. So we have the Kerberos table account, so users with service principal name. Quite important to understand because attacker will probably perform the same query. Then we have the pre-authentication disable query. So you should have 0 results for this query. And if you have a result, it's really easy to just disable this on the account. So it's really, really important. The members of groups through nesting is a great query, because when we do, for example, the net command on the administrator group, if we have a group inside the administrator's group, we won't see its members. We only see the name of the group. But using this query, we will see the members of the nested groups. And then we can actually know all the members of administrators group in our environment. And then I put two different queries for GPO. So you can't enumerate all the GPO information using LDAP, since it's not stored inside the LDAP attribute. It's located inside the sysvault folder in INF file, INI file, and stuff like that. But you can just enumerate the passes of your GPO files and the priority and stuff like that. So it's quite important, and it's a good start. And also, again, attacker will probably do the same. Now let's talk about ETW. So we have two ways to use ETW. The first one is on the client. So this is the Microsoft Windows LDAP client ETW provider. So actually, when you look at it, I use two tools, the ETW Inspector, which is a new great tool to just understand ETW providers better. And I also use the Microsoft Message Analyzer. So both are telling me that this client provider search a lot of different LDAP operations, for example, the bind and the connect and the unbind. But actually, when I used it, I only saw event ID number 30. So I think at least this is the most important event ID, because this is the search request, but this is all the information I was able to get from this provider. Maybe it's only on my environment, I'm not sure. So you can see the search filter here. So again, quite nice, really good start, because this will also show you the decrypted LDAP traffic. So this is quite a good thing to start with, but you won't be able to see ADWS using this provider. The second provider is the Microsoft Windows Active Directory domain service provider, and this one is located on the domain controller. But you need to do some configurations to make it work. So I put here all the configuration you need to do. And this one actually shows us the Active Directory web service information as well, because it documents events that occurred on the domain controller. So for example, here you can see the get ID user command output, and you can see in the IPv6 part, this is the local host IPv6, because ADWS is actually local host LDAP on the domain controller. So you can see the filter, you can see the attributes, and you can see the user, which is quite powerful. So I think this is the best way to monitor LDAP and ADWS traffic, but it's going to create a lot of events. So if you don't have the capability to store and process all these events, it's not that easy actually. So there is kind of a trade-off here. So let's conclude everything we spoke about. First of all, LDAP is very much alive. Attackers still uses it. There are new attack tools that uses LDAP all the time. Decrypting LDAP traffic is important. You may be blind to a lot of LDAP traffic in your environment, especially LDAP traffic that attacker performed. Monitoring ADWS traffic is important as well, since it can avoid any LDAP detection there is. So it's really, really important to understand there is another way to perform LDAP queries, and we don't know how to detect it yet. And you can easily discover misconfiguration in your environment using LDAP. So as I said, it's free, it's default, it doesn't require you that much of code lines. So it's really easy to do. I really recommend you to try it. And finally, you can monitor LDAP and ADWS using ETW. I don't think the word easily is correct here, because maybe it's easy to configure, but again, it's going to create a very, very big amount of events. So it's kind of a trade-off. Not every company can do it, but it's something you should keep in mind. And that's it. So that's it, basically. I would be happy to answer any questions on my email that I will provide to these slides. And I'm really, really happy that you came to listen to my talk, and I hope you learned something from it and that you enjoyed. And that's it.
TriMark Vision is the next evolution in the identification of security issues across all your Active Directory environments. The TriMark risk score is based on real-world expertise of TriMark's industry-leading Active Directory and Microsoft Cloud security experts. Most importantly, TriMark Vision helps you to answer the questions facing your Active Directory security posture today, such as what risk do I have in my environment? What actionable steps can I take today, tomorrow, this week to best mitigate my risk of an attack on my Active Directory? What should I be most concerned about within my Active Directory forest where it concerns potential attack vectors? What is the current security posture of all my AD forests? TriMark Vision, visibility at the speed of operations.